Okay, this is the review for your second test on exponents, factors, and fractions. I'm going to do all the problems on page 1 on this video. Problem 1 says to find a composite number between 50 and 60 whose prime factors have a sum of 11. So a composite number, it's not exactly the opposite of a prime number because there are some numbers that are neither prime nor composite, like 1 or 0. But a composite number is any number that has factors other than 1 in itself. So the ones that are not prime are almost always composite. Between 50 and 60 would include 50 and 60. So if I think of the prime factors of 50, I can make a quick factor tree. 2 times 25, and 25 is 5 times 5. We're looking for the composite number whose prime factors have a sum of 11, so that the sum of these prime factors is 12. 5 plus 5 plus 2 is 12. 51 seems like a prime number because it's odd and it doesn't seem like anything, it's divisible by anything, but actually it is divisible by 3 because 5 plus 1 is 6. So 51 is 3 17s. Those are both prime, and the sum of these is 20, so that doesn't work. 52 is 2 26s, and 26 is 2 13s. If I've got a 13, I already know the sum's going to be more than 11. 53 is prime, so it's not a composite number. 54 is 2 27s. 27 is 3 9s, and the 9 can be decomposed into 3 multiplied by 3. If we add these primes, 3 plus 3 plus 3 plus 2, that's 9 plus 2, that is 11. And so 54 is the composite number we're looking for here. Problem number 2 is a quantitative comparison problem. We want to identify the quantity for box A and then the quantity for box B, and then compare A to B to see whether A is greater than B, B is greater than A. Maybe they're equal, or maybe there's not enough information to compare them. So box A, the quantity for box A is the number of factors of 16. And because it says factors, it doesn't say specifically prime factors. I'm looking for all the factors of 16. So we use a UT diagram for that. 1 multiplied by 16, 2 multiplied by 8, 3 is not a factor, 4 is a factor, 4 multiplied by 4, and there's my U. The tricky thing about this problem is you have to realize when you're counting the number of factors, don't just count them straight off of here, because you're going to count 4 twice. If you were to make the list, you would make a list 1, 2, 4. This is also 4, so I don't need to show that twice. 8 and 12. So on a problem like this, a lot of people would incorrectly say that there are 6 factors of 16, but really there are 5. The number of factors of 22, so make a UT for 22. Oops, that's okay. 1 multiplied by 22, 2 multiplied by 11, 3 doesn't work, 4 doesn't work, 5 doesn't work. And so there's really only 4 factors for 22. 1, 2, 11, 22. So when you see a larger number, it doesn't mean it has, the larger numbers don't necessarily have more factors than the smaller numbers. So which statement is true? In this case, A is greater than B. Problem 3 asks, how many counting numbers less than 20 have 3 as one of their prime factors? And so, since this is a reasonably small number, maybe we'll just list the counting numbers less than 20. Counting numbers start with 1, like if you're counting on your fingers. 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. Why am I saying them out loud? They're pretty obvious. For 3 to be one of their prime factors, they would have to be divisible by 3. So 3, 6, 9, 12, the multiples of 3, the positive multiples of 3. Maybe that would have been a more reasonable list for me to make, but I wanted to make the point that counting numbers start with 1, so we're clear on what counting numbers are. If you list these counting numbers, 3, 6, 9, 12, 15, 18, they are, I almost just wrote multiples of 3, but to be more precise, 0 is a multiple of 3, but it wouldn't be included in the counting numbers, so let's say positive multiples of 3. Since 0 is neither positive nor negative. If I want to be really precise, I would say the first 6 positive multiples of 3. Find the least common multiple of 10, 20, and 24 to determine the lowest common denominator of the fractions listed below. Then use this to arrange them from least to greatest. So we'll use the LCM to find the least common denominator, and then we'll convert these fractions to that denominator. So let's start by finding the prime factors. 10 is 2 multiplied by 5. 24 is 2 multiplied by 12. 12 is 2 6s. And 6 is 2 3s. 20 is 2 10s. 10 is 2 5s. Make your Venn diagram. For 10, 24, and 20, and then look for prime factors that are common to all three. Like 2 is common to all three, so I'll cross 1, 2 off of each tree, place it in the intersection. The reason I cross it off all 3 trees is because this intersection is part of all 3 of these circles. So it's like it's as if I've placed that 2 and 3 in all 3 of the numbers. This 5 is only common to 20, and it's not common to 24, so I'll cross off a 5 from 10 and 20, and I'll put it in the intersection of 10 and 20. 10 is done. 20 just needs one more 2, and that 2 is common with the 24, so I'll place 1, 2 in the intersection of 20 and 24. And then I just need to place a 2 and a 3 in the 24 only. Then I check my circles. This circle is supposed to be 10, and 5 times 2 is 10. This circle down here is supposed to be 20. 5 times 2 times 2 is 20. And this circle should be 24, and I see a 4 here and a 6 here. 4 times 6 is 24, so that all looks good. Our least common multiple will be the product of the prime factors in the union, so all of these prime factors multiply together. I think it'll be easier just to start with these, because I know these prime factors make 20, and then 20 multiplied by 6 is 120. Then I have everything I need to know to convert these fractions. 7 tenths multiplied by 12 twelfths is 84 120ths. 15 24ths multiplied by, if you're not sure what to multiply by, look at the Venn diagram. This is 24, so there must be, you look everything outside of the 24 circle, it's just a 5. So 24 multiplied by 5 must be 120, because that's how we found the LCM in the first place, by multiplying all these prime factors together. If I multiply by 5 fifths, this is 75 120ths, and then the 13 20ths, we'll multiply that by 6 sixths, and that's 78 120ths. This is a really good example of three fractions that would be very hard to compare. You see that even when they're 120ths, even when the pieces are very, very tiny, they're very close together, 75, 78, and 84. So I don't really think you can do this in a much more efficient way than we just did. For least to greatest, we would start with the 75 120ths, which is 15 24ths, followed by 78 120ths, which is 13 20ths, and then finally 84 120ths is 7/10. Okay, that completes page 1 of the review. We'll pick up the review with page 2 on the next video.